Okay. What we're going to be talking about here is the difference between color modes. So we introduced the idea that there is a color mode that you can choose from when you're creating your document, but there's actually two types of color modes. And the reason I cover this is a couple of reasons. One, a lot of people don't understand the misconception on what they're sometimes experiencing out in the real world when it comes to color. And so it's a good opportunity to just kind of educate people who may not necessarily be in the field, but they've experienced this personally, either by someone sending them artwork or they see something on their screen and they print it out and it doesn't look the way they think it's supposed to, et cetera, et cetera. So we have two color modes, which you saw in that drop-down list. The first one is RGB and the other one is CMYK. You guys know what RGB stands for?
Red, green, blue.
Yep, red, green, and blue. And when do I want to work in RGB?
Digital.
What's that?
Digital stuff.
Yeah, yep. Anything that's going to be digital and digital only. So anything that I'm creating that I'm expecting people to only view on a digital platform should be built in RGB. So CMYK stands for cyan, magenta,
yellow, and something.
Yellow, and then they trick you on the last one, black. And so we want to work in this color mode for anything that's going to be printed. So the first reasoning then, or the thought process is, well, what happens if I'm going to show something on a computer screen, but I'm also going to be printing it out? How do I work in these different color modes? Well, ideally, depending on how stringent you're trying to be with your brand colors, or how consistent you're trying to be with the colors when people are viewing them on two different platforms, you're probably going to have a file that's built in RGB, and you're also going to have a file that's built in CMYK. Now, when you run into that situation, what you have to pay attention to is what's sometimes referred to as an out of gamut color. Out of gamut color, which basically means it's out of range. And so RGB colors, because we're viewing them on a computer screen, we have a much larger range of colors that we can work with. On the flip side, CMYK colors, we have a more reduced range of colors. So really what that means is that there are certain colors I can see on my computer screen that can't physically be printed with ink on paper. And that's where a lot of people run into problems is they create something on their computer screen, they love the color, they go and print it out, and the colors are dull or they're muted. Well, more than likely what's happened there is that the colors they're seeing on their computer screen are out of the printable range or out of gamut, and therefore they can't be printed at that high intensity, and therefore the printer is actually printing the only color that it has access to that is as close as possible to the RGB color that was selected. So when you're going to work in these two different environments, of course, you're going to want to work within RGB colors that are within the gamut. And there are some certain indicators within Illustrator as well as the other Adobe products that will help you identify whether the color is actually in gamut or out of gamut, and then some of the things that you can do to correct them. So again, RGB is going to be for anything that's digital, the web, video, mobile platforms, etc. CMYK, of course, is going to be for the printed version. Then the other thing that we always talk about, or I always talk about, which helps people sometimes understand too, the results that they're getting with things, is there are two types of graphics. Now, I'm not talking about file types. I'm talking about the two types of graphics that you can actually work with. Anybody know what one of those is?
Like raster?
Yep, there you go. Raster's one. What's the other one?
Vector.
Yep,
Yeah.
vector. Yep. And so when we think of raster images, we typically think of photos, and the application we think of is Photoshop. Now, that doesn't mean that we can't bring in raster images into Illustrator. It's just that's not what Illustrator was originally built for. Illustrator was originally built for vector graphics. And vector graphics simply means this, that when you draw an object, that object has points and then the lines or paths that connect those points. So when I create a square, that square actually has the 4 corner points and then the paths that connect those points. And there's pros and cons with these different graphic types. So the one benefit with vector artwork is that resizing it does not affect quality. So in other words, I could have a 3" by 3" square or illustration and blow it up to 6 foot by 6 foot, and it's still going to look just as good. Or vice versa, I could have a very large graphic and shrink it down, and it's still going to look just as good. On the flip side, raster images, or photos for the most part, when you resize them, it does affect the quality, or for the most part, it can affect the quality. The other thing that's unique about raster images is that because of this resizing, which can affect the quality, we have certain levels of quality that we have to determine as far as the files that we're working with. And so what you saw in that dropdown on the new document page, which said 300 PPI, PPI is our unit of measurement in which we determine the quality level of that raster photo. Do you guys know what PPI stands for?
Mm-mm.
Pixels
Drew?
per inch.
Anything?
Pixels per inch, right?
Yep. Pixels per inch. Pixels per inch, okay? Now, just giving you a history lesson, it used to be referred to as DPI, which was dots per inch. And they're the same value. So if I said 300 PPI or 300 DPI, it's the exact same thing. It's just a change in terminology. The reason the change was made is because DPI represents printing. Dots per inch, it's the physical ink dots that get printed on a page. If you've never zoomed in on an actual printed page, the colors that you're seeing, they're not solid colors. They're actually little dots, either cyan, magenta, yellow, or black. And depending on the size of those dots and how close they are to each other, it gives your eye the illusion of the color you're actually seeing. And so in this case, you'd have 300 within an inch space. Well, since we've transitioned to a digital age, they just simply coined the name differently, and now we refer to it as pixels per inch, okay? So the main reason I say that is if you're talking to a printer, an actual person who's running the printing press, in today's environment, most of those people are in their 50s and 60s, because we don't have too many young people that are out there actually running these printing presses. And so they might be using the term DPI in a conversation. It's exactly the same thing. So if you're talking PPI and they're talking DPI, exact same numbers. And what this refers to is what we say the resolution or image quality. And so you have 3 levels of it. You have high resolution or high res, you've got medium, and then you've got low. And that resolution is determined based on the pixels per inch. So for something to be considered high resolution, ideally it should have 300 pixels per inch. If something's medium resolution, it's going to have 150. And low resolution is going to be 72. And the platforms that you're normally going to work with these different types is going to be high resolution for printing, medium resolution for newspapers, and low resolution for web or digital environments. Now, again, just kind of a history lesson here. 72 has always been the default for low resolution. However, with today's environment of our computer screens becoming more prominent and more precise, if you will, that value can actually be bumped up to 96. So in some cases, if you see somebody that's created a document that has 96 pixels per inch, you still understand that it's for digital usage. We're just trying to bump it up for people who have computer screens that have a little bit better image quality. And so again, that's where this concept comes into play as far as where people look at something on the screen and then they go and print it out and it doesn't look as good as what they saw on their computer screen. A lot of the times the reasoning behind that is your computer screen is only showing you an image quality of 72 pixels per inch. Doesn't matter what your actual document has in it. Your computer screen is only showing you the 72 quality. So it's going to look good on your screen no matter whether it's a low resolution or high resolution image. But it's not until you actually print it out will you see the discrepancy if it's not a high resolution file. Okay, and that's where a lot of people who don't understand the concepts of imagery, they'll be looking at their computer screen or they download an image from the web. They don't understand or didn't recognize that they downloaded a low resolution file. They go and print it out in their newsletter and all of a sudden it looks crappy. Well, that's why, because you didn't have a high resolution image. Although it's going to look good on your computer screen, it's definitely not going to look good when you